I'm Marley.
And I'm Jacob.
And today we're going to talk to you about bubble rings. You may have seen bubble rings in a pool, or maybe the last time you went scuba diving, but just how do these rings form in the first place? Bubble rings gracefully rise to the surface and are mesmerizing to watch. Today, we'll explain the fluid mechanics behind what makes these rings possible.
Why does the air on the right form a ring, while the one on the left does not? After you watch this video, you may begin to understand why.
First, we'll talk about how a small bubble quickly leaves the mouth with a small radius. As it rises to the surface, it forms a beautiful ring of a much larger radius.
The ring structure is maintained by a toroidal vortex, which circulates around the ring as it rises.
In addition, the higher a bubble ring rises in the water, the larger its final radius. Let's walk through this step by step.
A small sphere of air exits the mouth quickly enough to rapidly displace a volume of water. This is called a cavitation bubble. The water in a given volume is rapidly displaced by the bubble, and the pressure drives the water to fill that space back in.
The pressure acting on the bottom of the cavitation bubble is greater than the pressure acting at the top. This larger pressure pushes the bottom of the bubble upwards faster than the bubble itself is rising. This causes the bottom surface to meet the upper surface, forming a ring shape.
The water that rushes through the newly formed hole in the bubble initiates the toroidal vortex that maintains the bubble ring.
But why does the bubble ring get bigger as it rises? Well, at the bottom of the pool, the pressure is high due to the amount of water above, so the air molecules in the bubble are densely packed. As the bubble rises to the surface, the pressure decreases, allowing the air to expand, thus making the ring larger.
In addition, the bubble ring accelerates as it approaches the surface. This causes the toroidal vortex that surrounds the ring to accelerate as well. Due to the conservation of angular momentum, the vortex must reduce its radius to compensate for this increased vortex speed.
This smaller vortex radius squeezes the bubble ring, making the ring thinner as it rises. To compensate for the thinner ring, the radius of the ring must expand to create the same volume. This also contributes to the ring growing in diameter as it rises. Thus, the diameter of the bubble ring increases, while the radius of the toroidal vortex decreases.
Maybe now you know enough about bubble rings to jump in a pool and try making some yourself. Thanks for watching.